We're talking today about logarithms, and logarithms are a function that is the inverse function of an exponential function. And so they are very closely related, inverses of each other. And one of the things you can do with logarithm equations is you can rewrite them, the same equation, in exponential form. So I'm going to show you how to do that. If you have, and vice versa, if you have an exponential equation, that would be, you've got some kind of base, you have an exponent with an x in it, and then it equals something else. This would be an exponential form equation, or an exponential equation. You can change that into a log equation, or change a log equation back into an exponential equation by rewriting it. And what you do is you write the word log. You take the base number that's under the exponent now, and you shrink that down to be the base of the log. Then you take this number over here, which now is a, and it equals the exponent. I would like you to be able to easily go back and forth between these two forms. It helps when we're solving just multiple types of equations throughout this chapter. And so I've thought of something called a log loop trick that helps you go back and forth between them. And again, you can go back and forth, log to exponential, exponential to log. And what you'll do is you'll kind of do a loop around the equation. So you start with the b, write that there. Go around, loop around, grab the exponent, write that as the exponent, come back around, get the thing that you haven't touched yet, which is the a, set it equal to a. So b to the x equals a. Works the same way here going back. You'd first write the word log, and then you'd write a b, and then you'd write an a, and then you'd loop back around and write the x. So I'm going to try that here. And see if it helps. So here I've got log base 4 of 64 equals 3, so I'll do my loop. 4 to the 3 equals 64. Oops, I wrote x, sorry. 4 to the, I'm going to start over. 4 to the 3 equals 64. All right, same with this loop. Because it's already exponential, I'm going to change it to log, so I'll write the word log. And then I'm going to get my base of 343. So log base 343 of 7 equals 1/3. So we've got a couple of examples on the back. And these are just regular log expressions because they don't have an equal sign in them. And we're going to evaluate. So when you're talking about logs, when you are answering a log question, the answer will be the exponent. So it's asking you 3 to the what exponent would give you 27. Sometimes you'll just know the answer, and then this one is 3. 3 to the 3 equals 27. Sometimes 4 to the what is 1/16. Sometimes they're a little bit trickier and hard to think of on the spot. So with those, I would recommend making it into a log equation and then switching into exponential form with a loop. 4 to the x equals 1/16. From here, you can go and use the same base or the one-to-one strategy that we've been covering. You can try to get there to be at the same base on both sides, so then you can disregard the bases and just set the exponents equal to each other. So I'm going to try that here. This side there's a 4 as a base right now, and this side there is a 1/16. Integer bases are always going to be easier to work with. So here I have a 4. I'm going to try to make this side be 4, or have a base of 4. So the first thing I'm going to do, I'm going to leave this side alone because it already has a 4 as a base. I'm going to rewrite that 16 as something that it equals, and that is 4 squared. So since 4 squared equals 16, I can replace 16 with 4 squared. So I've rewritten the entire equation. It looks like this. Now I'm going to move this 4 squared to the top of the equation. So I have 4 to the x equals 4 to the -2. And my rules of exponents are, if you have a term with a positive exponent on the bottom, when you move it to the top, it becomes a negative exponent. You change the sign of the exponent. So now I have a 4 on both sides. I can cancel out my 4, and x equals -2. My next one, 7 to the what equals 1. Switch to exponential form quick. 7 to the what equals 1, and that's one that you have to know your properties of exponents pretty well to know that, and anything to the 0 power is 1. So in this case, it's 0. Last, if you don't know the answer, set it equal to x, switch forms, 8 to the what equals 2. 8 to the x equals 2. And on this side, I have a 2, and on this side, I have an 8. So I'm going to go with my smaller base. It's usually easier to change them both into be a smaller base. So here I have a base of 2. Here I'm going to try to get this to be a base of 2. So 8 is actually the same. Oops, I don't want an 8. 8 is the same as 2 cubed. So I'm going to take out the 8. I'm going to put in 2 cubed. 2 cubed to the x equals 2. Now I have a 2 on both sides. I can cancel out my 2's, and here I have an exponent with another exponent, so I multiply those to get 3x. Here I have a 2 to the invisible 1, so I'm left with a 1. So as I finish solving, I get x equals 1/3. So example 6 is 1/3. A couple special bases that you'll see. If there is no base, like it looks like it's missing a base, that's going to be an invisible 10. It's called our common logarithm, and we don't write the 10. We just skip it, and we automatically know if there's no base, it's a 10. This is a natural logarithm, and a natural logarithm has a base e. So when you see ln of 5, it actually equals log base e of 5. Up here, log of 16 actually equals log base 10 of 16.